Hi, I'm Lisa and welcome to my channel. Today I'm going to show you how to use the first version of CombatGraph. CombatGraph is a completely free toolkit I developed. It's designed to help you create complex combat interactions for your own games. In this video, we'll cover how to perform basic attacks and auto attacks, how to send data from the graph to UI like sliders or floating numbers, how to hook into events within CombatGraph, how to add variability for different NPCs using the same graph. I also walk you through CombatGraph features, including the buff system and the different attack types you can use in this version. To get a full understanding of everything CombatGraph can do, just watch the entire video. I promise it all makes sense, but if it doesn't, or if you have any other questions about CombatGraph or future updates, feel free to drop a comment under this video, fill out the Google form or join our Discord. Now let's get started. To begin, I've created a test scene with two characters, the player and NPC. I control the player with the keyboard, while the NPC finds its target, the player, and follows them until it's within attack range. At the moment, attacks are just locked in the console. There is no damage or HP yet. Let's add combat graph so our scene can display health, damage, and other combat elements. The game will remain simple, without complex mechanics, but it feels much closer to a fully functional combat system. I want to point out that I use the simplest possible setup for this scene, just a few components on a mono behavior, with no frameworks. Your project structure might be different, and that's totally fine. The key is that combat graph can be added the same way in any setup. To add combat graph, right-click in your project, select Create Combat Graph, and then rename the new asset, for example, Default Combat Graph. Next, add a combat entity component to the desired game objects and assign the newly created asset to it. The idea is that combat graph stores the data for your combat model, while combat entity implements its behavior. After that, double-click the combat graph asset to open the editor window. Arrange it into Unity so it's comfortable to work with. Here we see the main stats block. There is a few core attributes like health, mana, attack, defense, crit chance, and dodge. If your game doesn't use mana or crits, you can simply leave those values at 0. This won't affect combat graph functionality, it will work correctly and performance won't be impacted. To get started, let's set the core parameters, health and attack. I set health to 100 and attack power to 10. Next, I right-click the workspace and see a menu with options, attacks or buffs. For now, we'll leave buffs for later and add a basic attack. In the pop-up window, I give the attack a name, Sword Hit. This is the attack ID and it's need to be unique. Combat Graph automatically prevents duplicate names, but it's best to give clear, meaningful names from the start so it's easier to reference them in the code later. Then I set how much damage this attack will deal. By default is 100%, which means it uses the full attack power defined in main stats, in our case 10. The other fields can be left as is for now. Now let's hook our attack into the gameplay. I open the scripts that handle the combat system. In this project we have the following components: enemy attack, player attack, weapon, hitter. Enemy attack and player attack are controllers that handle attack events, like when the player press button. Weapon and hitter handle the actual attack logic and check whether it hits an enemy. At this stage, we don't need to dive deeply into the logic of those scripts. They implement it as simply as possible. Instead, let's focus on updating player attack. First, we add a reference to the combat entity component, so we can use it inside player attack. Next, we look at the update method, which handles the key press, in my case, the X key for attacking. Right now, it calls the attack method on the weapon, but it doesn't yet know the attack type, damage, or who is performing the attack. To provide this information, we call combat entity attack before calling weapon attack, and using the ID of our attack, sword hit. The combat entity attack method returns an attack data structure, which we store in variable. Then we pass both the structure and the combat entity itself to the weapon's attack method. At this point, weapon attacks turns in red. That's normal because we haven't updated its method signature to accept these new parameters yet. Let's move to the class. There the weapon attacks method is defined and see what it does. This method starts like a routine, which is used for a simple visual effect, a sword flash, to show that an attack occurred. But the main damage logic happens in for each loop, where the method getHit is called for every object with a hitter component. The hitter component is added to any game object that can be hit. It's automatically added to a list of targets when it enters a trigger. On trigger enter to D and removed when it exits. On trigger exit to D. So when an attack happens, weapon simply iterates through all the hitter components in the pool and calls getHit on each. Now we want getHit to receive not just a signal that an attack occurred, but also data about the attack itself. That's why in weapon attack we pass both attack data and combat entity. The latter can be logically renamed to damage dealer. And that's it for weapon. Now let's move to the hitter class and update the get hit method signature to accept attack data, combat entity, damage dealer. Inside the hitter class, we need to get the combat entity of a target, that is, the one receiving damage. For this, we use a serialized field combat entity damage taker. Next, we call the take damage method on damage taker, passing in both attack data and damage dealer. To make sure everything works correctly, we can log the current HP to the console using the current HP property of the entity taken damage. The last piece is enemy attack. Its logic is exactly the same as player attack, so now the full chain works like this. The player or enemy calls combat entity attack with an attack ID. Combat entity returns an attack data structure. This data is then passed to the combat entity that receives the damage along with a reference to the entity that deals the damage. In my setup, this happens through weapon and hitter. Now I run the scene and as you see everything works. The console shows the current health values and damage is actually being applied. But let's step back for a moment. Why do you through all this? At first glance, you might think it would be simpler just to add HP and damage variables directly in player attack or enemy attack. To see the benefits, let's open our CombatGraph again and experiment with the parameters in the main stat blocks. First, I tweak the crit and dodge related stats. Crit rate 50%. This means half of the attacks have a chance to be critical. Crit damage 100%. A critical hit will deal double damage. Dodge rate 50%, so the target occasionally dodges attacks, making these events visible in the gameplay. After setting these values, I run the scene again. Now you can see occasionally critical hits occur, doubling the damage dealt. But sometimes attack are dodged and no damage goes through. This is where the usefulness of CombatGraph becomes clear. It allows you to easily manage those combat mechanics without complicating your controller logic. All of these features are scalable and highly customizable. And that's, of course, not all. Right-click in the workspace and you'll see a list of available buffs. Each buff has a detailed description in the documentation. I tried to make it as clear and comprehensive as possible. Now, let's look at a couple of concrete examples. We'll start with Healing Persistent. These buffs allow health to regenerate over time. Healing Rate, how often the health is restored. Heal Amount, how much health is restored each time. Effect Chance, the probability that the effect actually triggers. For example, if you set effect chance to 50%, even when the time interval passes, regeneration will only occur half the time. I add this buff and run the scene. In the console, you can see the health periodically regenerating. Now let's look at a scenario where an NPC learns to dodge attacks. We add dodge rate increase, a buff that raises the chance to dodge. Then we configure it. Event type. Set to on dodge, so the effect triggers every time the character dodges, like a learning process. Additional dodge amount, how much the dodge chance increase each time. For us, it's 10%. Max additional dodge amount, the maximum bonus the buff can provide. For example, if the NPC dodges 3 times, their dodge chance would increase by 30 but not higher. If you add multiple buffs on this type, their effects stack. I run the scene again and can see in the console that the number of successful dodges gradually increases. This confirms that dodge rate increase is working correctly. Now let's take a closer look at the additional parameters available for attacks. For example, open our basic attack. You'll see that besides the name and damage, there are several interesting options. Ignore defense and shields. This parameter disables the effect of defense and shields. Defense work like this. If a character has high defense, a main stats parameter, the incoming damage is reduced. For example, a 10 damage attack might only deal 3 HP. Shield acts as temporary protection. As long as it's active, damage doesn't affect HP. You can add a shield using the shield buff. If Ignore Defense and Shields is checked, damage is applied directly to HP. The damage formulas and examples are detailed in the documentation. Delay after attack. This acts like a cooldown. It specifies how long to wait before the attack can be used again. For example, if set to 1 second, the same attack can be used again 1 second after execution. Attack duration. This is the log time for all attacks. While this duration is active, no attacks, even other ones, can be performed. This is useful for long animations, ensuring that NPCs don't switch to the next attack before the previous one finishes. I set the following values: delay after attack 1 second, attack duration 0 and 2 seconds. Next, we go into the scripts and remove the custom cooldown logic that was previously written manually in player attack and enemy attack, including last attack timestamps, cooldown checks, the cooldown time variable. All of that is no longer needed. Now, before calling weapon attack, I simply check the attack data to see if the attack is currently available. If it is not, we exit the method. This check is added to both player attack and enemy attack. I run the scene and everything works perfectly. Now an important point. How do delay after attack and attack duration interact? Do they add up? The answer is no. They run in parallel. Example: delay after attack 1 second, attack duration 1 second. In this case, as soon as the attack duration ends, the attack becomes available again. This means the NPC could attack continuously without any pause. If you want a real pause between attacks, set delay after attack greater than attack duration. For example, attack duration 1 second, delay after attack 2 seconds. Here there will be a 1 second pause between attacks, and the attack itself will last 1 second. The last important parameter is ready on start. Imagine you set delay after attack 6 seconds. At the start of a scene, the NPC won't be able to attack for first 6 seconds. That's the initial cooldown. If you want the attack to be available immediately, just check ready on start. Let's dive deeper into the attack system. Now our NPC attacks automatically, but it bypasses CombatGraph. Let's fix that and connect the built-in auto-attack feature. First, open the enemy attack script and create a script method. Important: use start, not awake, because CombatGraph initializes in awake. If you trigger auto-attack before initialization, it won't work correctly. Now call the method combat entity start auto-attack handle auto-attack. The start auto-attack method takes a delay gauge, a function that will handle attack data returned each time the auto-attack triggers. I create a handler with a void return type and a parameter attack data. Inside, I use a switch statement to check the attack name, and within it, I call weapon attack. Reminder: the attack data attack name field is the attack ID set in CombatGraph. Finally, temporarily comment out the code in update that previously handled manual attacks. We run the scene and we can see that the auto-attack works, but the NPC starts attacking before it even reaches the player, which looks strange. To fix this, we use two methods. Prohibit attack disables one attack. Allow attack enables this attack. Go back to the update method and uncomment it. Whether we already check the distance to the player at these new functions. Now the NPC won't attack until it gets close enough and will stop attacking if the player moves away. Run the game. NPC approaches, starts attacking, player moves away, attack stop. This method are also useful beyond just distance control. For example, if you have a boss with multiple phases, you can use the same CombatGraph, but enable or disable different attacks at each phase. For instance, in Phase 1, only basic attacks are available, and in Phase 2, you can add area attacks or special abilities. One more thing to note: if you feel that your NPC's behavior is too complex to be conveniently handled with CombatGraph auto-attack, you can always use the regular attack method from combat entity instead. Actually, everything was working perfectly fine even without auto-attacks, right? But often, a player or enemy has multiple types of attacks. In that case, it's much more convenient to use the start auto-attack method. So let's make our CombatGraph a bit more advanced and add a mana-based attack. If you look at the mana attack fields, they're almost identical to a regular attack. The only difference is an extra field that specifies how much mana is consumed when using this attack. I fill in the fields as follows: name the attack, bullet hit, set the damage to 50% of the base, and configure the duration and effect timing. As you might have guessed, this won't work yet. Our model doesn't have mana, so I add 100 mana to main stats and set how much mana the character will have at the start of a game, or when combat entity resets. You could leave it at 0, but then mana would need to be restored through other means like buffs. There is a buff that constantly regenerates mana and another that triggers on specific events. For my example, I'll choose a different approach. At the start of a fight, mana is 100%, and then it's gradually spent, similar to a charge system. Now, to make this work, I go into enemy attack and add an additional case to handle the bullet hit attack. For now, I just leave a comment indicating that it needs to be implemented and write break. Next, it's time to create the bullet itself. Let's keep it as simple as possible. Of course, you can implement the mana attack however you like, but I'll make a flying orb. Create a circular sprite and color it red, since this attack is currently for the enemy only. Add a trigger collider. Move on to writing the script. A quick note: in real project, it's better not to go in this way. The movement of a projectile is usually handled by a separate controller that manages all bullets, keeps a pool, and reuses them instead of creating and destroying them every time. But since this is a fast tutorial, we'll use the quick and easy approach. In this script, we first set up the bullet's movement in update. We'll need the following parameters: speed, lifetime, direction, layer mask, to specify whether the bullet should damage the player or the enemy. Next, I create a spawn time variable to remember when the bullet was created. In update, I move the bullet in the specified direction using transform and the given speed. I also check whether its lifetime has expired. If the bullet lived long life, I destroy it using destroy. Now let's handle collisions. I go to the weapon class here. Hits are registered via hitter. I copy the logic, but instead of adding the hitter to a pool, I directly call its attack method because the bullet works differently from the sword. However, there's a problem. I don't yet have the required parameters for this method. We need attack data and damage dealer. So we create an initialize method for the bullet, where we pass in attack data and the relevant combat entity. Inside this method, I initialize all necessary fields and also set spawn time and direction. That's all we need for the bullet to function. Finally, we create the bullet in enemy attack at the location where we left the comment. I initialize the bullet by adding a serialized field for the prefab, performing the instantiate method, and then calling initialize with the correct parameters. Now, when we run the scene, we can see the mana-based attack flying out of the schedule. Now, I want to point out that so far, all interactions are being tracked only in the console. This works, of course, but it's not very convenient, so let's move on to handling the user interface. We'll start with sliders, since they appear in almost every game. As an example, let's make an HP slider. In the canvas, I create a standard slider and configure it. Remove the default handle, adjust its length so it fills completely between the minimum and maximum values, change the color to red, position it where I want. Next, I create a class HP slider. It will have fields for the combat entity and the slider component we just made. Now we can simply update the slider in update with just 2 lines. Set the maximum value from max HP. Set the current value from current HP. Run the scene and everything works perfectly. But I also want to show another approach using an event manager. In this case, the slider updates not every frame, but only when HP change. To do this, in start, I get a reference to combat entity and called add listener. The first parameter is the event we're subscribing to, in our case, on HP change. And the second is a function that will execute when the event occurs. The function can be lambda, but I rename our old update to update HP so it doesn't run every frame and pass it into add listener. Save and run. Now the slider updates only when it actually needs to. And that's not all we can do with Event Manager. A very useful feature is that we can not only trigger events, but also pass parameters along with them. To keep things simple, let's start with an easy task, adding floating numbers about the NPC's head that appear when they take damage or are healed. First, we need a canvas. I create a new canvas and switch it to world space, so it exists within a scene and can display directly above the characters. Again, I note that in real projects, it's better not to constantly create and destroy these objects. Instead, you should use an object pool to reuse existing instances. But for our tutorial, we take the simple route, creating and destroying the numbers in a naive way. Inside the canvas, I add a text mesh pro text component. This will display the number. I line it up so it looks right with the player and enemies. Next, I create a floating numbers class to manage the behavior of each individual number. In this class, I add the following fields: lifetime, how long the number will exist; speed, how fast the number will rise; text mesh pro text, a reference to the text component. In update, I implement 2 actions: move the number upward, transform position plus vector up, multiply speed, multiply time, delta time. Gradually reduce the alpha channel of a text color so it fades out, and destroy it after lifetime pass by. I also create a setMessage method. This method takes string text, the message to display color, the color of the text. Inside, I simply update the text value and set the desired color using TextMesh Pro. Now that we have a script for an individual floating number, we need a controller to decide when and which numbers to display. I create a new class, Floating Numbers Controller, MonoBehavior. In it, I add a field of type CombatEntity, a reference to the combat entity we are tracking, NPC or player, a field for the floating number prefab, the object with the script we made earlier. In start, we subscribe to the event that triggers when the combat entity takes damage or it's healed. Previously, we used combat entity event manager at listener without specifying a type. Here, we need an event with data, so we use the generic version with angle brackets and add damage data. This struct is returned by taking damage in combat entity and contains information about the damage, the amount of HP lost, and status flags like critical or dodge. Next, we create a handler function in which we use the functionality from the previous class to display the floating numbers. We create an instance of the number and called setMessage. Inside this function, we check if the attack is critical, display the damage number in red. If the attack is normal, display it in white. We pass this function into addListener, so it's automatically called whenever the damage event on damage taken occurs. Next, I add our new component to both the player and the enemy. Both have health and can take damage. For each component, I assign the floating number prefab and the corresponding combat entity. Done. Now, when they run this scene, damage numbers appear above enemy's head when hit, red for critical hits, white for normal attacks. The same works for player. When the enemy attacks, the corresponding number appear above the player. So far, our handler is only subscribed to the damage event on damage taken, but we can make the system richer by also displaying healing. In CombatGraph, we add a healing persistent node, just like we did at the beginning. Now we subscribe not only to on damage taken, but also to the on heal event. The on heal event returns an int, the amount of health restored. We write a handler function similar to the one we had for damage, with a few changes. Add a plus sign before the number, set the text color to green. After this, when a character is healed, green numbers with a plus appear above their head. Damage numbers still appear in red or white, depending on whether the hit was critical. Now let's look at one of the most obvious use cases for the event system in CombatGraph. One of the key events that can happen to a combat entity is death. When an NPC or player dies, many different processes usually trigger in a game, so it's crucial to track this moment. In my current script, there isn't a single component managing all NPC or player actions. Ideally, there would be a central entry point to handle the death event and immediately disable all functionality. But I won't implement that here. Instead, we simply stop the NPC from attacking once the player is dead. To do this, I modify the enemy attacker class. I add a reference to the player's combat entity. Instead, I subscribe to the OnDeath event using addListener. When the event fires, we call a special method reloadEntity, which fully resets the model, removes all buffs, and stops auto-attacks. After making these changes, I assign the player's combat entity in enemy attacker, run the game, and now after the player dies, the NPC stops fighting. A complete list of all events is available in the documentation, where you can check the return types and detailed descriptions. Now let's look at how to create a UI and functionality for the player's mana attack. Currently, the player uses the same CombatGraph as the enemy, so the mana attack parameters are identical to the enemy's attack. First, we create a prefab for the mana attack. We already have the bullet class used for the enemy. We can simply copy the existing buff, keep the same class, but change the bullet's color, and update the layer mask inside bullet. This way, all the functionality is ready for the player to use. Next, we move to the player attack class. Add the bullet prefab through a serialize field. In update, detect the key press for the mana attack. Let's use Y. When the key is pressed, call the attack method on combat entity and press the attack ID, in this case, bullet hit. If attack is unavailable, simply exit the function. If it is available, create the bullet object with instantiate based on the prefab. As you remember, for the bullet to work correctly, we need to call the initialize method. We pass in the result of combat entity attack, the bullet movement direction. The direction is determined via transform Euler angles. If the Y value is 180 degrees, the player is facing right, otherwise left. We use vector free right or vector free left. I actually use a slightly more robust approach to account for floating point inaccuracies. Now everything is ready and we can test the mana attack. It works perfectly, but there is still one nuance to address. If you look inside CombatGraph, you'll notice that the attack has a delay after attack parameter. However, the player's UI currently doesn't show how long until the mana attack is ready, nor do we display the current mana amount. First, let's implement a display for the mana attack cooldown. I suggest adding a slider to the UI, which will decrease as the ability regenerates, along with a text field showing the number of seconds until the attack is ready. In the U-class Cooldowns display, we declare the following fields: slider, the UI element showing the cooldown process, temper text, text field displaying the remaining time, combat entity, the entity, those skill timer we are tracking, in this case, the player. String attack name, the name of the attack for the mana attack, bullet hit. These fields are set via the inspector. In update, we access the combat entity and set get timer attack name, which returns the timer object. From the timer, we use time to reset, current value for filling the slider, cooldown time, maximum value for the slider, time to reset in seconds, remaining time in seconds, rounded up, cooldown time in seconds, total cooldown in seconds, also rounded up. Here, check the variable types of these fields. All of them are floats, except for ones with the in seconds suffix. This way, the slider visually shows the regeneration progress and the text displays the numerical countdown in seconds. Finally, add the Cooldowns display component to the player object, link it to the relevant UI elements and test it. My UI looks a bit weird, but using this data you could create something more aesthetic, like animated clocks or something. Now, for completeness, let's create a slider to display the player's mana. Essentially, this is not exactly like the HP slider. We'll create a similar class. Let's call it mana slider and implement the same logic. The difference are: instead of subscribing on HP change, we subscribe to on mana change. And instead of using current HP and max HP, we use current mana and max mana. Now, when the player uses a mana-based attack, the slider decreases, showing the current mana amount. Now let's move on to the most practical feature of CombatGraph. This system allows you to create a common base for enemies and then easily add variability within a single enemy type with just a few lines of code. To demonstrate, let's go to an example. We move to a different scene with 3 NPCs standing in a row and a weapon that can hit them. I've also added floating numbers, the one we created earlier, to visually display damage, as well as HP sliders above each NPC. Next, I create a new CombatGraph. For now, I only add a basic parameter, HP 100. I attach this CombatGraph to each NPC in the scene. This weapon that moves through the scene and hits enemies is assigned the default CombatGraph, the one we created earlier. At this stage, all NPCs are identical. They take the same damage. Now we'll create a few scripts to introduce variability into this system. First, let's add simple random-based variability. To do this, I create a class random variation modifier. The only field needed is a reference to the combat entity that this class will modify. Instead, I access the combat entity and call add buff. We pass in one of the buffs we want to apply. All buffs available in the standard editor can also be initialized through code. In this example, we use the defense increase buff. To do this, we create a class with the same name and initialize it with the following parameters: event type, for example, onInitialize, addition type, overliner or percentage. Liner, the number is added directly to the base stats. Percentage, the number is calculated as a percentage of the base value. Buff amount, how much defense is added. Maximum buff value, a limit to prevent the effect from growing indefinitely if triggered multiple times. Effect chance optional, default is 100%. In our case, we generate a random number between 0 and 100 and use it as both the current and maximum buff value. To add more variety, we can use a switch and randomly choose other modifiers, for example, persistent healing or invincibility, full immunity for a set duration. After this, we save the scene and run the game, and we can see that the damage NPCs take not varies from one to another, even though they all use the same CombatGraph. Next, let's add a variation based on the NPC's level. To do this, we create a new class, level-based variation modifier. In addition to a reference to combat entity, we add a level field, which is set individually for each NPC. Example modification. Defense, increase as the level rises. HP also grows with the level. To calculate the HP and defense values, we use a simple formula that depends on the NPC's level. After that, we say the class and attach it to the NPCs instead of the random modifier. Now, by changing levels, you can observe how each NPC's HP and defense adjust accordingly. That's basically everything we've done through the entire interface that CombatGraph currently provides. If you have suggestions or ideas, you can leave them in the comments via the Google form or the Discord channel. I hope you enjoy using CombatGraph. See you next time.